In the last video, we started talking about the propagation of uncertainty through a linear regression, and we used the example of the standard error in the slope as an estimate of how uncertainty in our observations propagates through the linear regression analysis into uncertainty in our parameter estimates. If we take this bit of code that we had before, where we are defining an intercept and a slope for a known intercept and slope, we are creating some data for our independent variable. We are then making predictions or model of our dependent variable based on our independent variable and our known intercept and slope. And then we are adding on some artificial error based on randomly sampling from a normal distribution. And finally, doing a linear regression analysis on those artificial data. And in the last video, we went over how if you do a summary of the results from the linear regression, you can get a table of statistics that tell you something about your uncertainty in your parameters. For example, I will rerun this code, and I can look at that LM summary, which is a list, and there's an item of that list called coefficients. And that is a matrix of values with names for both the rows and the columns. And what we're interested in terms of the standard error of the slope is this number right here. Remember, the slope is going to be named the same thing as the name of your independent variable. And the standard error here is here in the second column. So you can think of this as basically like the standard deviation of our uncertainty in our slope. So now the goal is, and what a major goal of the homework is to give you a more intuitive understanding of where that uncertainty comes from in terms of how it propagates through that model. And it basically comes from our uncertainty in our observations, which we ultimately have control of. Remember, we've got this standard deviation set to 2. That is basically a metric of our artificial error that we're creating in our data. What if we change that number? What if we make that number smaller? What if we make that bigger? Well, that should have a predictable effect on the propagation of uncertainty through the model, and we should see smaller or larger values for this standard error in the slope if we change that. So how do we write some code that allows us to do that? And that's our next goal in terms of writing a loop that will let us run this analysis more than once, such that we'll have a vector of standard deviations, of different standard deviations that we want to try, and then have a vector of the resulting standard errors in the slope that we can compare to each other in a figure.